All right, I can see it is 3 p.m. So there will be a premium for all those who joined exactly on time. And thank you for you. So I will now get started for this webinar. Welcome. And let's go. Good morning and good afternoon, depending where you are located. My name is Axel Framatome. I am in charge of developing digital solution activities within Framatome with my colleagues in the business units. I am glad to welcome you to this webinar series on digital solutions for nuclear and critical industries. We will address different topics today. This is the third webinar of this series, and if you had a chance to attend the previous ones, we covered different topics such as operations, maintenance, engineering, and as I will clarify a bit later on, the topic today will be largely focusing on digital solutions for decommissioning and dismantling activities. As usual, this is a very concrete webinar series. We like to take experiences and examples from the field as close to concrete example as we can. This is not a theory class on what can be done with digital. It's really about engaging in discussion with you in the audience about very concrete examples of applications. Next slide, please. Yeah, sorry, that was me, and I'll go directly onto this one to give you a few housekeeping items before we get started. First, be aware that this webinar will be recorded, so the content can be shared later on. The duration will be approximately 60 minutes, which will include 45 minutes of presentation plus 15 minutes of Q&A. So if you don't mind, we will take questions at the end of the webinar. For raising questions, we would kindly ask you to use the chat function at the lower right of your screen, not the Q&A. The chat allows this to be shared more easily across participants on WebEx. And when you do chat, you can share the questions with all panelists, so that all panelists on the call today will see your question, and we will answer them throughout the end. I think this is it for the chat, the housekeeping items. Now let's get to it. Safety first, safety message first. As you may know, at Framatome, we like to start each meeting with a safety message because safety is really at the core of our DNA, and you'll see examples later on. So take care of the people around you. That's the first, of course. Don't hesitate to say when you say something, when you see something that should be mentioned, when you see something that could cause a security issue or safety issue. Don't consider yourself as protected from those kind of situations because you are, if you are in an office. Remember that safety is also for people sitting behind the desk. There are a number of accidents currently due to commuting. People not being very careful commuting with icy conditions, depending where you are. So in the core of the winter. So keep that as clear in your mind. Be mindful as well of data security, so that we like to call the data pickpockets. Cybersecurity is a strong area of concern, and in our industry, so nuclear and critical industries, this is a raising concern that we all need to be very conscious about and keep that clear in our mind to make sure we are adopting the right cybersecurity practices and good habits. Thank you. Let's move on. Very brief intro for those of you in the audience who may not know Framatome very well. Most of you in the audience is likely to know Framatome already quite well. So we are a world leader in the design, manufacturing, and maintenance of nuclear reactors, often referred to as NSSS, which is the right component where we focus largely on, as well as associated fuel supplies, so fuel from engineering to manufacturing and to operations as well. We are providing digital solution throughout the life cycle of nuclear plants. So as you can see at the bottom, from new nuclear project, often referred as new build, to plants in operation, to long-term operation, extended operations, and throughout plant after final shutdown. And what's interesting today is we will focus particularly on digital solutions which are specifically relevant to that step in the plant lifetime. All right. Be also mindful that we also operate in other critical industries, such as defense, healthcare, transportation, and others. Those are industries who share with us a common focus on safety, security, and performance. And they typically operate in very critical and highly regulated environments. So we are building from expertise in evolving in those type of industries. And that means we have a slightly different way of designing digital solution with those aspects in mind. Next, please. I'll go briefly for 1 minute over the main areas where we focus on with our digital solutions. And what's important is to mention that we are focusing on addressing concrete and practical industrial issues. This is not a technology-driven portfolio, but really focusing on where we can bring some value to critical industries and power plant operators in the field. So safety first, cybersecurity and compliance is the first item I will go through. This has become, this has always been an important aspect in maintaining the safety and security of industrial assets. We provide here software and services, the solutions that can help to identify vulnerabilities, protect assets, define the risk analysis and mitigation plans, so auditing, as well as system hardening or patch management solutions. This will not be covered today in this call. Second aspect that we focus on largely for digital is typically referred to as digital INC for operations and control systems. This is inherited from solutions that are currently deployed in a large number of modernized nuclear plants with Framatome Digital INC, and that we are complementing with dedicated real-time control and predictive systems for assisted operations and plant maneuverability. So an array of solutions on that segment for plant operations and control. Third item is support to augmented engineering solutions. And here we have solutions that are here to reduce the cost of complex engineering, namely by facilitating the design stages, reducing the risk of errors. Last time in the last webinar, we discussed an early validation simulation tool, if you remember. And today there will be also elements that will be touching on this. Number 4 here I have on the list is augmented operators solutions. These are solutions meant to facilitate the performance and safety of field operators. By field operators, we mean workers either in the shop floor, industrial shop floor, or in operating in the power plant. Those are two very sensitive and critical environments for which we provide solutions for their safety, and we will have one today specifically, ensuring their safety during dismantling activities. And last but not least, an array of solutions for asset management and monitoring. These are solutions for supporting critical asset supervision and maintenance. And these include solutions for condition-based maintenance, asset performance, diagnostic or non-destructive testing, and the like. All right, you can come back if you have a question at the end of the Q&A. And now let's move on. I will introduce very specifically, and hopefully this little video will start with the topic today, Yes, it works. So as I promised, we are going to focus today on decommissioning and dismantling. And that's a very particular phase of the activities, which cover a broad array of potential digital solutions. And this very short 1-minute video is taking you through the different steps from system shutdown, which is the first step, to defining the different scenarios for the D&D activities, logging the right safety reports for licensing and commissioning, decontamination, and of course, dismantling activities, which at the end conclude with waste management. So it's interesting to keep in mind that D&D activities are long sequence of steps from shutdown to basically waste management and managing a green field. There are a number of steps which are involved here. I have one slide, next slide. Very briefly giving you some credentials from Framatome in this area. So we kind of think of Framatome as very involved for new builds and plants in operation, maintenance. Those are truly important activities, but there are a lot of engineering and specialized tooling and manufacturing which are done for D&D, for dismantling and decommissioning. As I said, this includes licensing, cost optimization, dose decontamination, dose optimization, and of course, used fuel optimized management. So those are areas we will touch upon with 3 examples today, keeping in mind that they are taken from over 30 full scope decontamination examples that we have worldwide, that we are involved with worldwide. Examples of these are in France, are Fessenheim or Superphoenix. And next slide, please. I will introduce our speakers for today. Yes, I am perfectly on time. And today we will cover 3 very concrete examples from solutions which are not only used for D&D, but they are very specifically relevant in those steps. They are also used during the operations, but then they are particularly relevant in the D&D sequence. The first one will be introduced by John Peters, who's a senior manager for products and innovation within Installed Base BU in the US. And John will present 2 solutions. The first one will be for cleaning internal pipe surfaces, combining ultrasonic device with the adequate software. And the second solution would be a LiDAR who can track the position of crane hooks to prevent hazardous usage situations and keep field workers safe. And the final example will be presented by Frank Kerfurt, who's a product manager for robotic solutions in Erlangen in Germany. And Frank will present a mobile robotic solution to optimize radiological measurements and documentation. So without further ado, I'll leave the floor to John, who will start with introducing the cleaning solutions from IB in the US. John, the floor is yours.
Hello, I'm John Peters. I'm the manager of products and innovations for the service group here in the States. And today we're going to talk a little bit about a few innovations that we have started to develop or have currently put in service that could be applicable both to balance of plant outage for the utilities and of course, as our topic today, decommission. So the first one we see as a challenge has to do with how do we go in and clean in a safe and efficient manner the internal surfaces of piping. That can be difficult at times, right? Because you can't take the pipes apart and you need to get that solution clean within the pipe itself. So this could be around contamination. This could be around mineral buildup. So as we look at that is how do we effectively do that without affecting the plant and the fluid flow through the plant? So in most of these objects, we're targeting one type of deposit. That's one thing that's good about the system that we're working on with the subcontractor is we want to be able to go in and target that area to be able to do that cleaning. And it could be very difficult for us to be able to do that if we're not having a technology to be able to do that, especially without delaying the plant. Next slide, please. Sound check, next slide, thank you. So as we looked at what was available to us, one of the main focus areas that we had to do, we had an actual application in a utility here in the States where we had hot spots inside the internal parts of those pipes. So what we decided to do was work with a subcontractor and be able to modify that system to be able to be applicable in our industry. So we were able to go in and do cleaning of up to 5 to 6 feet from where the transducer was to what we targeted. So being able to take this system and efficiently apply it to the outside of the pipe and direct the sound waves to get the contaminants off the surfaces and lift that up so that the fluid flow of the system can take that and move it down the pipe. So we felt, hey, what is a good way to do that and having a flexible system? So we worked to build basically a transducer belt. We were able to use transducers that did not affect the actual substrate or the material of the piping. And we were able to take that contaminant and move it down the pipe. There's over 100 applications with this tooling outside of our industry, with the main focus around areas like mineral buildup, contaminants that could be causing heat transfer loss, and able to clean things such as piping, heat exchangers, or other systems that may need a mitigation over a long term. So with this technology, we're able to go in and lift those contaminants off the piping and efficiently move it down the pipe. Next slide, please. So we're also in the same process, we're looking at what the next generation is. This is very applicable for us for areas such as when we go in to do inspections or mitigation of the liner itself. Those mitigations may be to have a surface clean, to do NDE inspections, and we're able, and you can see in the video there that's spinning on the right, we are developing with a subcontractor a process to do laser cleaning inside of those pipes. The great part of being able to use this technology, which we call next gen for us, is we're able to efficiently clean it. It's delivered by robotic equipment that we use in liners for coating, and we're able to get a near white surface condition. So that was important to us because in areas where you have to apply primers, that's very important for us. So would this technology be used to clean the entire surface of the pipe from one end to the other? Probably not, but it will give you an area where you can go in and concentrate on either high contamination buildup. It can concentrate on a tar liner that's on the side to be able to effectively remove that to be able to use the next process of your step. The other things that we looked about with this technology was the Department of Transportation in the States did a lot of testing with this. So does the operator come into environmental conditions with these lasers to be able to affect them from a health and safety standpoint? And though it has a small vacuum head that's built into this type of technology, it actually does very well at evaporating the contaminants. So we were able to use this technology to safe and efficiently clean the pipe without affecting any of the environmental standards, which is around that right now. The main challenge from an innovation standpoint with this technology is being able to get this into what we call small pipe or small bore piping. That's very difficult when you're using a laser. There's a lot of handheld lasers out there. You can see in the picture to the bottom left for the outside of pipe that's been used. But the technology that we're trying to work with and get this done is to be able to clean internal parts of pipe. As we mentioned, it's delivered by a robotics crawler, and that technology is very mature in how that will be delivered. So is there any questions on that? Next slide. So now we're going to move into talking about another innovative product that we're very excited about. It's around what we call crane hook tracking. So next slide, please. If you think about the existing plants and how long that they've been in operation, a lot of those cranes were not in a position to be able to pinpoint where they wanted to deliver the hook or the hook block. We noticed that was a utility request that we would look at this type of technology to see if we could develop something basically to retrofit an existing crane that was there. So what their challenge is how do you effectively pinpoint the crane hook and get it into a position to pick up the load and maybe even return the load back to its original location in an efficient manner. We've seen that with this challenge that the utilities had, it was really around schedule, right? If you had all the time in the world, you could just play around with the hook and get it where you wanted. But to efficiently move it, it was part of our optimization plan and how to be able to do that. And then when you're in our industry, it's really around dose. So we're trying to reduce the impact and the time around the load that may be radioactive and how we move that and get it into a position to be able to reduce the dose to the worker. Next slide. So as we started working through this, and this was not just a one-time development, we looked at sonar originally. We moved from sonar to LiDAR because we've seen how the autonomous mode of cars could get us in a position to be able to more effectively control that. So we looked at how could we track those loads in X, Y, and Z coordinates. And some of the biggest challenges with that is our utility partners said, hey, we need exclusion zones, right? We need the crane to not be able to go into this area. And unfortunately, operators, a lot of time when they're moving the crane, they're watching the crane flagger, they're looking up, and they can get into an area where it's not desired for the load to be there. So we were able to take a very robust software, integrate that in with our technology, and be able to move that to be able to track in an X, Y, and Z location. So we do believe that this software will have additional applications in the future. It could be around security, safety, but our whole mission was how do we use this capability to safely affect the use of the crane without the operator performing a human performance error. And that's all I have on the crane hook tracking. Thank you.
Handing over now to Frank.
Hello together, here is Frank Querfurt. From Framatome, Germany. I'm a product manager of some robotic solutions here at the INC business unit. And before I start, I want to thank my interesting engineers who are behind me. So for make this solution available. Yeah. So next slide, please. I want to start from the customer challenges. So before we started the project, we had to look at them. And as you know, we are in Germany, so there's a political decision to stop using nuclear power due to the catastrophe at Fukushima, but all over the world, mainly due to normal shutdowns due to end of lifetimes. There are several, or there's a huge number of nuclear sites that had to be processed by D&D, and for this process, so to know which workload you have to be aware of, there's a need for a lot of radiological measurements that have to be done, and after that, quite maybe a lot of more steps. It came to the material release and characterization process, where measurements have to be performed, like you see in the right pictures. It's so-called clearance measurement, where you see an operator holding an measurement with his measurement device, so it's so-called contamination monitor, for several seconds, so for quite some time on an area, and he for this measurement, he has to hold it with contact to the area, and this has to be done for all areas, for all square meters that have to be that are planned for final release. So, for example, in case you are under a certain radiological value, it can be processed in a normal disposal processes, or the normal disposal way. And if, for example, you find a hotspot, or it's like, because it's over a certain degree of radiological contamination, it has to be processed very specially, of course, and that's the aim of this measurement. And there are huge numbers of those measurements, and though we thought could be a good idea to go into to start an optimization project to cover that, but not only to cover the workload and of those people on site, but also to to make the documentation in a applicable in a digital manner. So in the second picture, the operator documents on site, so he's marking hotspot, or he's marking the surrounding of the measured area, giving some numbers on it. But of course, this has to be documented, maybe on in a database of the customer side, or in paper or digital manner. And with our project, we also address this documentation of surface areas. And as we are, of course, also aware of security, so the principle of ALARA, as low as reasonable, achievable, is one challenge we want to address, because when you use a robot instead of a human, of course, you can reduce the exposure time of that human. And so that was the start of our project. It's called Autonomous Mobile Robot for Automated Clearance of Buildings and Structures. Here. Next slide, please. While the video is running, it's if it works, I want to talk more about the developments we made. So in a video, you can what is also available on YouTube. We can share the link if you want it. you can see first prototype of our idea, and yeah, and on the right picture below, you can see what kind of developments we had to address to make this use case of clearance measurements. And for example, yeah, we need the mentioned spray marker, because we want to be, as you maybe see in the picture, we want to make a use case that is in the same manner than so very adopted to the real action on site. So that and for that we need this. We decided to implement this spray marker. So with the spray marker, Amarok can mark as an operator, hotspots like giving a cross or making or surrounding it with his spray pen, or showing the area where he has measured, for example. And additionally, we included cameras. For instance, for making photo documentation and for other purposes. So now it's running, thanks. And of course, we need to implement the contamination monitor, like our measurement device. What is in this case, for this use case, a contamination monitor that has to be pushed to the wall. What can be a wall, can be a floor, it can be something else. And additionally, what is very important, as in the project before, we need a LiDAR system, a LiDAR sensor, in order not only to make the digital twin, but also to make sure that our Amarok can make localization in the environment he's operating, and this localization has to be as accurate as possible, because this use case requires a high accuracy, because the measurements had to be done sometimes twice, because once for the real measurement to collect the data, and for example, second for an authority to recheck it. So we need this opportunity to go again to a measured place and redo a measurement, for instance. Of course, we addressed also the general automation benefits, like saving time, costs, reduction of errors due to this standardization, and what I already mentioned with this LiDAR development, we created a digital twin where we operate on, and what is also possible to use for, of course, other use cases. And next slide, please. Yeah, and I'm really proud to present our first action on site with this development. Namely at a German NPP running company called RWE. So very thanks to having this action on site to them. And here I collected like a small roadmap how it works, and what's special here, I talked about walls and floors and ceilings. So on but now we do the same measurement for a 20 feet container, so for a transport equipment. It's feasible because it's the same measurement type for clearance in this case, and before Amarok can start his autonomous task or job, we have to make a pre-scan, a 3D pre-scan, in the manner that Amarok is making one round around the object focus. So in this case, it's a sort of transport container. And after this is done, we have the data, so the digital twin in our database, and an operator can plan the jobs, meaning he can define the areas what had to be autonomously measured by Amarak. So, and when Amarak has a permission to do it by the operator, he can pick the job and just walk to the area where the object is, the container in this case, and for instance, starts with measurements insights in the middle picture where you can see the agility of the basic system. So of course, a board from Boston Dynamics, and mounted with our developments on it. And on the third picture, you see also the marking system having been used, I would say. So you see these rectangles. For instance, these were defined so jobs areas by the operator, and for each rectangle, Amarak has measured in fully, so completely he's making this rectangle. And if there would be, for example, hotspot, he would make he would mark it, or he can also write something on it. So the marking system is quite flexible, also with different colors and so on. And yeah, please click again on the slide, then you can finally see the result. That's point 4, the automated documentation. Due to we have everything in our database, we can generate a document, printable or digitally, or we can make an interface to the customer database to share our or the results of Amarak. So yeah, that's it for that slide. Please, next slide. And yeah, so this is where we are, would say, quite at the moment. So we have some use cases. So like I would say Ally label, or very soon applicable, I would say, like the ones I showed you here, and like for the radiological correct station, so the clearance of transport equipment, or like we addressed in the beginning, like the clearance of walls and floors and ceilings. Additionally, we have the we generated a digital twin, so a digital map of the real environment. So with this, a lot of other things are possible, and we added here some more. So like the periodic round for radiation and protection, or like a remote surveillance if you would make use of a high resolution camera that, for instance, was already tested by Boston Dynamics at Los Alamos under heavy radiation conditions, I would say. And yeah, a lot of more things are possible. Hopefully I can, or we can show you more soon. Thanks, that's from my side.
All right, thank you, Frank. Let me take the video back. So thank you to our experts, and John. Thank you, John, and thank you, Frank. We will now switch over to the Q&A session. For that, maybe we need to transition the slides as well. Yeah, let's go. Let's keep in this slide. So first of all, the purpose of those webinars is to give very concrete use cases. So don't hesitate to reach out to John and to Frank later on and ask them some follow-on question if you want to have one-on-one discussions with them. But for the time being, I will now go towards the questions that have been raised. First question was if you can hear me, and maybe Frank and John, you can put your camera back on and your microphones back on so they can you can answer the questions. The question I think was for you, John. First is how much material thickness can be removed from the pipe using Gen laser?
So The Gen Laser is all about trying to create a near white surface. So it really is applicable to what the surface condition is, but we try to keep it below 1 mil of thickness that we go. But sometimes when you have heavy oxidations from rust, you have to go a little more aggressive to that. It can do that, but it's more time consuming to be able to create that. I hope that answers your question.
Okay. The second question is from Thomas. When do you think you have the prototype for laser cleaning of pipe internal surface ready for operation and testing?
Can you repeat that question? I think that's mine, but we can.
Yeah, right. That was for you, for you, John. When do you think you have the prototype ready for operation and testing?
And this is the internal next gen laser pipe cleaning?
Correct. For laser cleaning
yes.
of pipe internal.
So we have to differentiate because the ultrasonics are currently available. Right now, we see that for pipes 6 to 12 inches, we'll complete the testing in Q2. That'll be ready by the end of 2023. For pipes 12 to 24, because as you can understand, the bigger you go, the more equipment design you have to do for that. We don't expect that to be complete until the end of Q4 of 2023. So I would say probably Q2 of 2024, 25 would be the target for us.
Okay, excellent. Anyone on the bridge, if you want to raise some question on this particular solution while we are discussing it, please, you're most welcome. Otherwise, I will continue the list and hand over, I think, to Frank with a question on Amorak. And I'm back on the chat. Can Amorak also take measurements on walls or ceilings, or is it limited to the floor or max 1 meter wall height? As it looks like in the picture, it's true like it looks like the robot itself can only take measurements to up to a certain height.
Yes, it can measure on walls and ceilings, so that's possible. So that's foreseen. It's not limited to floors, but it's of course limited to height. So it's more than 1 meter. It's 1.5 meter. We are limited with the arm mounted, not having any other extensions. So yeah. So hopefully this answers your questions. And maybe to give another. The idea we have is that there's one thing is a huge workload, even if it makes the floor and 1 meter 50, for instance, it can cover a lot. And we also want to couple it with manual measurements, so that is both linked to the same database and tracked, and so we are aware of that, and we are also thinking about how he can go higher, for example. So as you have seen in the video, he can walk on steps, so we could make some maybe after having done 150, he can go climb on something to make the next level or something like that.
But you're not going to teach him to climb the walls, huh? That's not
no.
That's not the purpose of the discussion.
No. Okay.
But actually, it's a good transition to a question from Alexander hereafter, who first thanks us for providing practical examples that facilitate the understanding of the solutions. Yeah, that's that we will introduce the videos of the solutions in actions when we can. And this webinar was a bit easier because we mixed digital solution with robotics, and that's exactly your question, Alexandre. Hereafter is how is that part of the digital portfolio, and is robotics considered digital? We have included those solutions here because they really are combining both aspects. The robotics for the data capture, and each time you've seen there's a software to analyze the data that is captured. For Amorak, maybe I can let Frank explain, but the data that is captured by the robot is about, dosimetry, mapping, and also documentation. So I think there's a software that goes together with Amorak to exploit the data that is measured and captured. Can you maybe give a few examples of post-analysis of the data that Amorak captures that is done as part of the solution?
Yes, of course. So with the raw data we collect, so it depends on the measurement device. So we have several options of collecting data. So before we can do analysis, and then when it's on the database, yeah, it can be analyzed. It can be presented in several manners. It can be linked to other databases. So what I think is digital issues. So for example, in the future, think of operating Amorak or other units on the plant with being linked to a general database where humans can access and get informations out or give general jobs, and robots like Amorak can do them. Though I think it's the digital is a link between human and robotics, for example. So.
Thank you, Frank. See that actually, indeed, Shafaf had provided some answers to that. There was a question connected to cybersecurity. Is it considered digital? So definitely, it's tightly connected to it, especially for two different aspects. First is like safety by design. When we design software solution, we have to design them with cybersecurity and safety by design principles in mind. And that's one aspect of it. And the second is, can this be operated in the field, considering the cyber context? So are we including those capabilities to encrypt the flows when it's required, because there are confidential exchanges which are happening? Those are examples that we see in the field. Are we not hosting the data in environments which are exposed, typically like a public cloud? And those type of considerations. All right. I see there is also another question which actually is true for both Amorak, but the question here is asked to John for the robot crawler for pipe cleaning. Is it hardened against radiation? It probably is. How much gray? And maybe we can ask the same question about radiation hardening for Amorak on the second stage. But first, I will let John consider the question for the.
And just to clarify your question, this is on the end pipe crawler and cleaner?
Correct.
Yes, so that's part of our testing requirements. We have not completed that at this point, but we see that we'll be operating in an environment very similar to how we can support on the primary and secondary sides. We do not see that as an issue. If we get into cameras and grain, it'll follow the same principles that we use for our red hardened cameras. So we do not see that as an issue also, since we're able to operate them around nuclear fuel.
Okay, thank you. And while we're at it, can you clarify as well, there's also another question on what ultrasonic pipe sizes can we perform?
Yeah, for the ultrasonics in particular, we're able to go down to 1 inch, 25 millimeters. So very small size for doing the cleaning. Keep in mind that transducers are placed on the outside of the pipe, and we've got a very innovative saddle to be able to go down to that small pipe. Currently, what we've tested, we can go as, we went up to 48 inches. That's 1.2, 1.21 meters with external pipe clamps. But the way the belt is designed, we're capable of adding links to that size to add on. to make that larger. So we do not see that as an issue as we get into larger bore piping.
Excellent. Thank you. And same question for you, Frank, about the hardening against radiation. I think that's very relevant, of course, for Amorak.
Yes, so for this clearance use cases, it is not so relevant because we do not expect so high radiation, but in general it is of course relevant. And despite we are planning to make radiation tests for parts of our equipment, if it's how it behaves under radiation conditions. So our supplier Boston Dynamics did quite complete test for a system in the facility of Los Alamos in US, where the spot, so our base platform with an arm, was collected really high doses up to several numbers of sievert. So I think it was much more than lethal doses, and they do not recognize any issue. So it should work. Yeah. So of course we do not have this test done by ourselves, but that's good thing is that our base platform spot and this supplier Boston Dynamics has is looking on the nuclear market and wants to does test by themselves. But we want for of course we have a lot of equipment there, and for equipment we think it should be clarified. We are doing tests at Framatome.
Excellent. Thank you, Frank. Question from Olaf for the positioning crate hook LiDAR. Are there any reference plans where you have LiDAR improvements or solutions in operation?
Oh, that's a good question. The system that we used with sonar was a Gen 0 type design. We were able to go in and efficiently move from center of vessel to headstand and back efficiently. Our challenge is that's a triangulation. So you have to have line of sight to be able to do that. In LiDAR, though it's able to do a lot more of mapping, it also requires a form of line of sight. But we are able to put those sensors in different areas. We put them up on the crane, and they're able to pinpoint that. We've done testing in our technical training center. We continue with that, but the first pilot for this technology will be this fall of 2023. Everything we've done so far has given us above expectation results, even to the point that we can see shadowing from the crane hook, and being able to protect people, of course, is our main focus. So we see some very positives coming from this system to protect not only the operator, but the people that work in and around the crane.
Very good. Thank you, John. I think I'm going through all the questions that have been raised, making sure I'm not forgetting any. Hold on. Discuss product availability and references, both of the three. Okay, I think we covered just about everything. So I will wrap up this webinar, thanking you for attending and introducing the next one. So there was a question on digital and robotics. The next one is really going to be on robotics. We will really be focusing on three very specific robotic-driven solutions, again for D&D or waste management. So if you're interested in this area, I would recommend you attend the next one as well. And we will send announcement through the Framatome Live channel pretty soon with the exact date. It is expected to be run mid-March. So basically, we'll keep a habit of having every 2 months the presentation of concrete use cases to you and in this audience. So stay tuned, we will receive that. If you want to know more details, you're welcome to visit our solution portfolio on the website on framatome.com, and we'll try to provide for each of the solutions presented not only as very specific product information, but each time as we can, we like to also provide use cases, reference customer testimonies. How does it translate in the field in concrete situations? We hope you appreciated this seminar. It seems like we're receiving a good number of positive notes about the concrete applications we were able to show to each of those examples. So I hope you liked them. Don't hesitate to get back to us, make suggestions. We are even welcome to co-present something with you. And digital nuclear is a long haul process. So it's not just about getting the right solution, it's getting the right use case and the right adoption. So thank you for your time. Thank you for attending, and speak to you in 2 months from now in the next Framatome Live webinar. Goodbye.